thank you very much for the introduction. I spare you my own introduction would have been the same. I'm the main person behind Gitoxide right now. And ideally, after this talk, you will know better what it is, and maybe more importantly, what it is not. And maybe that too, what it wants to be. All right, but after the previous talks, I think it's really important to stop here and discuss terms. Because there's so much about Git. Like there's Git2, which is the Rust crate that is the binding to libgit2. And libgit2, Ed, where's he? Okay, needs no introduction. Thank you, libgit2, for everything. Also the sponsorship, it's amazing times that we live in. Also thanks to Radical for making that sponsorship happen. It's great. Then there's Git. When I say Git, I usually mean the mothership, the main project. And now, as we just learned, there's also libgit.rs, which is the Rust crate that binds to libgit.a, which is the libification. I'm not going to talk about that. Mostly when I say Git2, I mean maybe libgit2. It's synonymous to me, nearly. So Gitoxide is the high-performance Rust crate that acts like Git would. And this acts like Git would is really important because it's a main differentiator to libgit2, which acts like a library that you have to control from front to end. If you want to make Git clients, in other words, Gitoxide is definitely meant to be for you. And then Gitoxide is also not only a library or a crate that you can use to make your own binaries, but it also comes with two binaries that are called Gix and ein. Gix is just a developer tool that does not try to be or replace Git, by the way. Gix is really just for me to be able to find out how stuff runs, how algorithms run in the real world. Whereas ein, as the, from Einstein, it's kind of the opposite of Git, because it might be one day a Git command line tool that you can use that makes it easier to use or interact with Git repositories. Didn't see much work, but ideally Gitoxide enables ein as well. Then the Gix part again, yeah, it is not the Git replica or anything like that, like I kind of spoiled before. But important to say that again. Nobody wants to create another Git binary copy, so to say. Gitoxide also isn't, unfortunately, as easy to use yet as Git2, the crate that binds to libgit2. So Git2 and libgit2, they're really, really usable, especially Git2. Git2 puts a lot of work on top that makes libgit2 easier to use. So if you are using Rust, you probably want to use Git2 if it comes to ease of use of API, or get started with that. Also, many great features. Yeah, Gitoxide also isn't yet usable from any other languages but from Rust. Whereas Git2, for instance, libgit2 can be used from any language on the planet, basically, because there are bindings to it, right? So C is this highly portable thing, great. And also Gitoxide is not stable yet, and probably not for a long time. This doesn't mean that it breaks your code every week, not even every month, but breaking changes can happen. And yeah, I'm mindful about that. Nonetheless, that might be an issue for some. And since we are here, everything is allowed, everything is possible, aspirations of Gitoxide in the far future, what could it be? What do I have in mind sometimes when I sit down and write code for this? Then why not make it the go-to library that is usable for anyone from any language? And based on my previous description of libgit2, Gitoxide kind of wants to be libgit2, right? So it's fair to shoot for the stars to maybe hit something, but you can try. Then, ideally, Gitoxide becomes the best choice for large monorepos, the fastest way to interact with these huge repositories that maybe even Git itself struggles with. The reason for this is that Gitoxide, and thanks to Rust, can parallelize much better, which means yeah, lots of potential performance improvements right there with every core on your machine. And, well, why not power an entire Git forge? Why not be on the server and be faster there as well? Because as I maybe said it a few times before, let's say it again, Rust is really a key enabler not only for Gitoxide, but also for writing highly efficient multi-threaded code. So yeah, let's be more efficient on the server, save some power. And maybe Gitoxide can be the most inviting for new features for Git. So if you have some idea that you want to prototype, why not implement it in Gitoxide first, bring it to the people to try, and then once you have something concrete, you can go to the Git mothership and say, look what I built, how can we make this happen in Git itself, in Git mainline? Yeah, who is crazy enough to use Gitoxide already? I'm starting with Cargo, who was the first to adopt Gitoxide. So the Cargo integration is ongoing. For those who don't know, Cargo is the tool that every Rust developer uses to build their code, to deal with dependencies, and so on. And they have a Git integration that runs partially on libgit 2, mostly on libgit 2, but also now some parts, more and more parts, become Gitoxide. Then there's RustSec and Cargo Deny. So those who want to manage their tool chain, be sure their licenses are right, make sure they don't miss any advisory. They use Cargo Deny, and that integrates completely with Gitoxide because they wanted to get rid of open SSH, and with the Gitoxide they could do that. Then there's Starship. I hope you heard of Starship. If not, you probably want to use it. It's really, really awesome. It's this terminal interface thing that tells you what you're seeing in your Git repository, and it got a lot of speed up by using Gitoxide, and I think it can get another 2x speed up once Git status is fully implemented in Gitoxide, so that's pretty cool. More parallel. And then there's OneFetch. OneFetch is a tool that allows you to see what a Git repository is made of, and it's fully powered by Gitoxide. By now, no libgit 2 anymore. Many speedups on the way, thanks to more multi-threading. And JJ uses it for parts of the backend, commits and such. Then there's Sapling. I don't want to say anything about it because I don't really know what they use. Maybe they don't use it anymore, but that's the last state I hear. And of course, last but not least, actually it would have to go to the front of the list, Git Butler. Yeah, Git Butler also uses Gitoxide in parts. Slowly, we focus on places where Gitoxide can make significant performance improvements to get better at big repositories, like the GitLab repository, which is our standard in trying, in big, bad repositories. So, and you might want to use it if you have a greenfield project that needs a Git integration, and of course uses Rust, where the Gitoxide features that are currently implemented suffice. Because you might not see everything you need. Maybe you can contribute what you are missing. And maybe you can even figure out how to use what's there by looking at Gig's repository, which is kind of your entry point into the world of Gitoxide. And I'm hinting at something here, which is ease of use, which definitely might still be improved, or should still be improved. And of course, if you need great repository compatibility. So you want to open every repository on the planet with all kinds of strange features that Git might have, then Gitoxide is also for you. Because I really, really want Gitoxide to not fail opening a repository just because it doesn't understand something. It implements a lot of, sometimes even very strange features of Git, just for that. And something I find very interesting, you can read untrusted repositories safely with Gitoxide. Because instead of just bailing out, it knows which configuration of the repository to trust and not to trust. So it simply will not execute any binaries that come from untrusted sources, as opposed to completely bailing out and doing nothing, which I find much more interesting as an approach, much more user-friendly. Of course, it also knows your Git configuration, so it knows what you consider safe anyway, just like Git and libgit 2 do. And definitely performance. If you want the best possible performance, you should use Gitoxide because then you get the fearless concurrency thing that that Rust advertises with. That comes with Gitoxide as well, just transitively, basically. And you have large amounts of data and need to churn through that, then Gitoxide is also for you, even right now. So this is a list of stuff that Gitoxide already implements. I think we have enough time to kind of go through that, but I might be fast about it. So what can you do today? You can read objects from the object database. and also write them. You can handle all objects, you can encode them and decode them. Also stepwise, which is pretty cool. So you can just partially decode a commit. If you're only interested in the author, you will only spend the time you need to decode the author, and the rest you can just drop. Saves time, and performance is important. Then there is the implementation of the ref database, but not ref tables just yet. So I heard from Patrick just today that he wants to contribute that, and I'm very thankful and very welcoming to that contribution. So maybe one day, Gitoxide will also implement ref tables, which helps with compatibility. And also shows that it can be really easy to contribute to Gitoxide, which is also something I really, really want. Then we have lossless git config reading and writing. And that's really, really a nice thing to have. It's really fast too. And of course, you can read and write the index, git ignore, and git attributes. That's this whole big machinery. If you've ever implemented that, it's quite a lot of work, but you can do it. Precious files in git ignore are also supported. And if you don't know that, that's cool, because it doesn't exist yet. Just a technical document implemented by Elijah. Thank you for that. Based on this, I could implement it in Gitoxide and use it for a Gitoxide tool that helps me to clean my own repository without killing precious files each and every time. So that's that. Nice. Then there's path spec support and rev specs and ref specs. Okay. And you can also read commit graphs, which is really useful for quickly traversing the commit graph. You know, it's like 10x speed up if you have a commit graph cache. And Gitoxide just uses this naturally. When you want to paint the commit graph, analyze, find merge bases, find what's ahead, behind, that is what that does, and it speeds it up. Commit graph support. You can describe commits like git describe, find the merge bases, perform fetch negotiations, and yeah, the high-level ref parsing. Then, of course, sorry for the long list, but it's really educational, so to say, so you really know what you can and can't do. And there's a whole bunch of diffing implemented. So you can diff trees with trees, the index with the work tree, and a tree with an index is unfortunately still missing, but shouldn't be too much work. Then you can find untracked files or classify the work tree, which is really just traversing the work tree and knowing what each file is. And that's really a fun implementation. Should look at the code. It just lives through tests because the logic is very, very complex, and the tests really drive that home. And if you look at the respective, anyway, let's continue with more stuff that it includes. You can do fetches, shallow fetches, use 3 different transports, SSH, HTTP, and Git native. Even though only HTTP and HTTPS is built in, the other just shells out to Git and SSH respectively, the binaries. So it's unlike libgit 2, which is fully inclusive, like fully built in. It doesn't make external calls. Gitoxide may make external calls, also a major difference. May call binaries. Then, you can also already check things out. You can also check things out very, very quickly as long as the target directory is empty, because they are part of the analysis that is needed to know how to do a git reset or a real git checkout into an existing work tree is not yet implemented. But checkout is really fast. It supports built-in filters and also custom filters, like git LFS will naturally work. That's pretty nice. Here, we have Gitoxide overlaid. Is there also a laser pointer here? Yeah. So Gitoxide is overlaid on what is Git from 2022. And everything in the background here, that's all the Git code base. Each pixel in this picture is a single character in the code, and it's colored like your color highlighter would. So this is why that looks pretty interesting here. And you see JGit is the biggest implementation. Right afterwards, there's libgit 2, and third is Gitoxide, written in Rust. And just for your reference, this was Gitoxide in 2022. So going back and forth, you see it grew quite a bit in the past 2 years. And then, just to be explicit about it, what it lacks. And many things are still missing that you might or definitely need to implement a full client. So we have the full status. You need the tree index diff, which is still missing. Can't create commits even, because you need index add and writing a tree from an index. And merging, also not yet implemented, but merging of blobs, like GitMerge file, that already works, even though it's very early still in development, which is pretty cool to implement, having great fun doing it. In progress, soon to be landing merge. And of course, it can't push yet, but it can build packs. So you see one little negotiation later, and it can also push. It's just driven by need, right? So nobody really needs to push with Gitoxide yet, so it's not implemented yet. Rebased can't do cherry picking, reset and checkout. All these things are not yet implemented, but it's really close because it kind of builds on top of each other. Once you can do one, the next one comes even more easily. And I'm really looking forward to finally getting there, because then one could say it's probably reaching feature parity to a great extent with libgit 2. And yeah, Blame. Blame is currently being implemented as a contribution, which is going to land in Git TUI first. Git TUI is made by Extrawurst on GitHub, or Stefan Dilly. And this is why I'm confident that this Blame implementation is going to be among the best. Like very fast, streaming data so that it's immediately processing, immediately showing something in the TUI, while allowing you to just keep working through your files without ever having some blocking, long-running operation. So it's stuff like that is usually pretty easy to implement in Rust, even though it's extra, as compared to, for instance, C. Then, yeah, how do I work? Principles during development. Correctness is first and foremost. So usually I try to generate baseline tests. So Git tells me what it does, and then I parse that back and take it as expectations for Gitoxide. So it's a great way to quickly generate a lot of tests that are based on what Git does, and then Gitoxide has to match that. On top of that, there are fence post tests to just set markers in this huge space of what you could test to be sure you get the basics right, sometimes based on documentation or based on actual Git tests. And of course, I leave generous notes, to-dos where corners are cut. Do a lot of documentation as well. While I know it, I write it down. And thanks to Cargo Doc, documentation looks great. So I'm really encouraged to write a lot of docs there while I'm not or having the knowledge. Fuzzing is something that is done to all parsers. Thanks to Google OSS Fuzz, many bugs were found, many panics were discovered, and consequently fixed. Now, this runs, funnily enough, through Gitoxide, other crates were also tested. So the fuzzer would find bugs in the URL crate, for instance, which made it panic, or which made it run for a long time, kind of exponential time. And all that has since been fixed. So pretty nice. Fuzzing is great. Performance. Gitoxide really tries to be mindful about allocations to not waste time. That's probably worth like 5% in typical operations, but these 5%, I think they matter. It does stepwise computation when possible, implements iterators of stuff, and also out of the box implements multi-threading. So sometimes you can pass threads argument, and if it's one, it goes with single-threaded implementation. Otherwise, it goes with all your cores right away. And that really matters. For instance, you can gigs clone something. And the gigs clone will clone the Linux repository in 1 minute 20 seconds on my my machine. And Git itself takes 2 minutes 20. Why? Because the pack resolution with Gitoxide is so much faster because it's so much more parallel. And you see all this kind of performance that you can unlock even today with today's Gitoxide. So imagine what's possible in the future, or maybe also what's possible on the server. Like, if this is a benchmark, then people who are better programmers than me might be able to do crazy things with the foundation as it's provided by Gitoxide. And of course, you do progress reporting, so your eyes can know what's going on, including interrupt handling, so long-running operations are naturally implemented like this. And yeah, I try to provide an easy-to-use API, even though it's not quite there yet, while also async support is available for everything transport-related. not for anything else, just the transport. So what goes over a wire. And of course, there's a lot of documentation that I linked up here, but I won't show that. Security is, again, last but not least, Gitoxide, even in its current state, has a dedicated security researcher. Elia Kagan is sponsored by the Radical Foundation and does nothing else but to find my bugs that could be exploited in the world. Many of them are exploitable on Windows, but some are also exploitable on other platforms, and great work that he does. I'm very thankful for this kind of work. In the remaining 14 seconds, this is how, the weakness, this is how Git 2 looks like. This was replaced just natively with the Gitoxide version. So you see that it's very noisy and not nice. Git 2 is preferable in this case, for sure. I made it so that it's less noisy, but it's still very noisy. And then I changed something unrelated here, the error type, and this allowed it to be written like this. And now it starts looking like a very fluent API, like I had it in mind when I was implementing this. And this is Gitoxide. It's more complex, but it's complex because it gives you a lot more access to what it's doing and to how it should do things. Yet, it's more difficult to use, especially if you come from Git 2. So that's the final comparison here. And you see, still a long way to go for Gitoxide. Thanks for listening. That's it from me.